So guys, we're going to continue on with chapter 1 today, and we're going to start a new section, section 1.3, prime and composite numbers. So I want you to write this down in your exercise books and underline, and pause the video, and when you're ready, come on back. Okay, so the first note for today is a note on multiples. So we've already talked about multiples, but I feel like some of you guys were a little bit confused about what a multiple is, so I want you to write down this note to make sure you really understand it. So a multiple is the result of multiplying a number by a whole number. So some multiples of 3 are 3, 6, 9, 12, 15, and so on. It just goes up by 3s. And these are multiples because they are the answer of 3 times something. So 3 times 1 is 3, and that's why 3 is our first multiple. 3 times 2 is 6, and that's why 6 is our second multiple. Okay, so some multiples of 5, same thing. 5 times 1, 5. 5 times 2 is 10. 5 times 3 is 15, and so on. So a little trick to always remember what's a multiple is multiples are always bigger than the number we started with. So multiples of 3 are either the same size as 3 or bigger. They get bigger as they go. So make note of that. Make sure it's in your exercise book. Pause the video until you're done, and when you're ready, come on back. Alright, so try this one yourself now. Write down review in your notebook. And I want you to list the first 5 multiples of 6. Try it yourself. Pause the video, try it yourself, and when you're ready, come on back, we'll check our answers. Okay, so 6, the first multiple of 6. Let's see what you got. 6 times 1 is 6. 6 times 2, 12. 6 times 3, 18. 6 times 4, 24. And 6 times 5, 30. So these answers, these are our first 5 multiples. We just went up by 6. 6, 12, 18, 24, and 30. So I just like to list it out in a sentence. So these numbers are the first 5 multiples of 6. Okay, if you got all of that right, great. Move on with the video. If not, pause the video, ask a buddy for help, or see if I'm available to help you out, because you must understand multiples before we move on. So we also learned about factors. We had multiples and then factors. These are 2 things we've learned about so far in chapter 1. I want you to write this down, because we talked about factors, but we did not get an actual definition down in our exercise books. So write this down. Notes, factors. Okay, factors are numbers you can multiply together to get another number. So for example, 2 and 3 are factors of 6, because 2 times 3 is 6. So it's numbers that you can multiply together to get another number. So we said, and I'm just going to flip back here, we said that multiples are always bigger than the number we started with, whereas factors are always smaller than or the same size as the number we were asked about. So you can see we're asking what are the factors of 6. There are 2 and 3. Okay, so pause the video and make sure you have that note down. Press play when you're ready. Okay, great. So we've practiced this a bit. Try this one by yourself. Pause the video and write this down in your exercise book. Find the factors of 16 using a factor rainbow, which you guys should be familiar with. So pause and give that one a try. When we come back, we'll look at the answer. Okay, so the answer. Okay, this is just a piece of the answer now, not the full answer. So if you use your calculator, okay, and you have 16, 16, and then we start with 1. 16 divided by 1 is 16. So our first factors are our answer and what we had on the bottom here, what we divided by. So 1 and 16 is the first layer of our rainbow. Okay, next, 2 and 8. So 16, let's just check that, divided by 2 equals 8. Alright, before we move on, let's try 16 divided by 3. Nope, we get a decimal, we don't get a whole number. So 3 is not a factor of 16, so it doesn't go on our factor rainbow. 16 divided by 4 equals 4. Okay, so this will go in our factor rainbow. We see here, and because we have either the numbers get really close together, and in this case they're the same, we have divided by 4, 16 divided by 4, 4, and 4, then we know that we've found all the factors. That's the little trick to let you know that you found all the factors and you don't have to move on and keep dividing. Okay, so this is the full answer, and just in my next slide here, I just pointed out the factors are the numbers you have on the bottom. All of these are factors of 16. Oh, I apologize, we got a typo here. Find the factors of 16. Okay, perfect. Alright, so now I want you to write this down, and we're going to see something a little bit special about these numbers now. I want you to try to find the factors of 2 first, and you can write it down in your notebooks. Just leave space. You're going to answer 3 of these questions now. Find the factors of 2, 3, and 5. So just pause the video, try all those 3, and when you're done those 3, come back, we'll discuss them. Okay, so factors of 2, 3, and 5. So if you put that in on your calculator, so 2 divided by 1 equals 2, so our factors are 1 and 2, and we know that the numbers are close together, so we can stop. Same goes with 3. 3 divided by 1. Okay, 1 and 3 are factors. But if we go 3 divided by 2, we get a decimal, not a whole number. So 2 is not a factor of 3. 5, same thing. 5 and 1 is good. 5 divided by 2, we get a decimal. So 2 is not a factor. It doesn't go on our factor rainbow. 5 divided by 3, same thing. 3 does not go on our factor rainbow. And 5 divided by 4, same thing. So the only factor would be 1 and 5. So if you draw factor rainbows for all those, whoops, you get factor rainbows with just one line, one rainbow curve. Okay? So the factors of 2, we only have 2 factors, 1 and 2. Factors of 3, we only have 2 factors, 1 and 3, and the same with 5, 1 and 5. So that's interesting. These are all numbers with factors, and the factors are 1 and itself. Okay? Now, I want you to try this one. Find the factors of 11, 29, and 31. Pause the video, come back when you're done. Okay? So here's our answers. Make sure that is in your exercise book now. Here's your answers. Same thing. If you check 11, I'm going to clear my calculator. 11 divided by 1. It's good. 1 and 11 are factors, but nothing else comes out to give you a nice whole number. 2 is not a factor. 3 is not a factor. 4 is not a factor. And 5 is not a factor. And if you keep going, you find that none of them are factors, only 11 and 1. Same with 29 and 31. So we see here we've got several numbers, 2, 3, and 5, 11, 29, and 31. All numbers with only 2 factors, 1 and itself, or just one curve on the factor rainbow. Okay? If you never got this for any of these, you made a mistake and got different factors here, I want you to pause the video and ask a buddy for help, or ask me if I'm available. If not, if you're good, let's move ahead. Okay, so here, write this down. This is important. This is a new keyword or definition that you should know in math. So write down notes. Keep your notes nice and neat. So notes, underline. And here is our keyword, prime number. Prime number is a number that has only 2 different factors, 1 and itself. So some examples, we found a couple of these. 2, 3, 5, 7, and 11 are some examples of prime numbers. A prime number has a factor rainbow, if you were to draw it out, with only one color or curve. Okay, so like we saw here with 2, 3, and 5, we just had the red. I always start off at red, just the one red curve. Same with these numbers. Okay, so for example, 11. We found 1 and 11 were the only factors of 11. So pause the video and write that down. Okay, so write this down. We're going to do this example together now. So the example, write that down, is 17 a prime number? Okay, and I want you to write down this hint. Use your calculator. Alright, so write that down in your exercise book. Is 17 a prime number? And the way we check this, all we have to do is check the factors. This is the same thing as asking, write the factors of 17. Okay, so you write the factors of 17, and then using the factor rainbow, using your factors, we ask, is 17 a prime number? So remember what we just talked about? I'm just going to flick back here. If 17 is a prime number, it will have just two factors, one and itself. It will have just one curve on our factor rainbow, one color. Alright, so let's use our calculator to try. So clear our calculator. So how do we check factors? We start 17, and that's the number we're asked about. 17 divided by, we start with 1, equals 1 and 17. Perfect. So these are our two factors of 17, 1 and 17. So I'm just going to write that in on our thing. So 1 and 17. Okay, so I'm going to move that down. 1 and 17. So that is our first curve on the rainbow. I like to draw a red curve. So 1 and 17. Now, do we have any more curves? We go back to our calculator and we try 17. We try our next number divided by 2. Okay, we have a decimal here, so this is 2 is not a factor. These are not factors of 17. Okay, we keep going up. This is just review. We know how to do this. We know how to do factor rainbows. No, not a factor. 3 is not a factor of 17 because we don't have a whole number here. 17 divided by 4. Nope. 17 divided by 5. Nope. 17 divided by 6. Nope. 17 divided by 7. Nope. 17, keep going. Divided by 8. Nope. Okay, and we know that we've checked everything now because the numbers are actually going down and we're getting closer to 17. So if we would have found another factor, it would have been up here already. Okay, so this is our only factors, 1 and 17. So we have one curve, so what does that mean? That means yes. Okay, 17 is a prime number. Okay, so pause the video, make sure you have that written down in your notes, and then we're going to move on. Alright, so try this one on your own. I want you to make sure you write down the question here, and then give it a try. Is 23 a prime number? So pause the video and give that a try. Remember that all you have to do is find your factor rainbow and see if there's only one curve on it. Okay, so by now you should have this done. If you don't have it done, if you're stuck, pause the video and ask me for help if I'm available, or ask a buddy. Okay, if you have it done, let's check. Okay, the answer is yes, 23 a prime number, because if you go to your calculator and you try 23 divided by 2, say, you get a decimal. 23 divided by 3, you get a decimal. 23 divided by 4, no whole numbers. The only time you ever get a whole number is 23 divided by 1. You get a nice whole number. Nice neat whole number here. So once you draw the factor rainbow, you find it only has one curve, which means yes, it is a whole number. Okay, try this one and try it on your own. Is 39 a prime number? Okay, so pause the video, write down your instructions, and give that one a try. If you're having trouble, ask a friend, ask me for help if I'm available, and when you're ready, come on back and we'll check over the answer. Okay, so it's 39 a prime number. So I come over here and I check 39 divided by 1. Anything divided by 1 always gives you a nice neat number, which means 1 is always a factor. Okay, but is anything else a factor? Okay, if we have two curves on a rainbow, okay, we're out of luck. It's not a prime number. Okay, so 39 divided by 2. Nope. 39 divided by 3. Okay, here we have the whole number. So 3 and 13 are factors of 39. So we've already found another curve on the rainbow. If we draw our factor rainbow, we have 1 and 39, 3 and 13. Okay, so we know that because we already got another curve, no, 39 is not a prime number. Okay, if that confuses you, please pause the video and ask me for help. If not, you're ready to move on. Okay, now I want you to get out your sheet from yesterday or last class, whenever, with where you colored all the multiples of 2, 3, 4, 5, 6, 7, 8, and 9. So it should be a nice colorful sheet. Okay, I want you to pause the video and make sure you got that ready. Okay, and when you come back, I want you to have your pencil ready, or a black marker or a black lead. If you need to get that, pause the video, make sure you're ready before you move on. But when you're ready, I want you to put a black dot, a black mark in 1. And that's the last mark we'll put into our 100 chart with our multiples. So pause the video, make sure you have that done. Okay, once you have that done, okay, so we got all these different marks and colors or stripes in our 100 chart. What I want you to do now is grab your black lead or your black marker, and I want you to actually color anything with color in it black. I want you to just cover up all the work you did. Okay, so I want you to color anything that you put a mark in. So you start with 1, you color that black because it has the mark in the corner. 4 will be colored up because it has a mark in the corner. 100 will be covered up because it has marks. So anything that has a color in it that you work so hard to do, I want you to cover it up with black now. And your result should be something like this. Okay, so pause the video, and I want you to color in your chart and color everything black. And there should be certain numbers that are left uncolored. Okay, so this is the result. Okay? And these are our prime numbers up until 100. Okay, there are more prime numbers than just this, but these are our first few prime numbers. Prime numbers less than 100. So 2, 3, 5, 7, 11, 13, 17, 19, and so on. These are all prime numbers. What does that mean? These are numbers that only have two factors, 1 and itself. They only have one curve on their factor rainbow. Okay, so with that being said, let's make a note of that. All right. Sorry, we already made a note of that up right here. Okay, so let's just review that. No need to write this down. You've already written it down. The prime number is a number that only has two different factors, 1 and itself. Okay, prime numbers. All right, so what are the numbers that we colored in black? What do you call numbers that have more than just two factors? Okay, and that's the next thing I want you to write down. So, write this down in your exercise book. Notes. Okay, notes. Okay, composite number. All right, a number greater than 1 that has more, actually we should highlight that, has more then two different factors. So composite number, a number greater than 1 that has more than two different factors. So this includes a lot of different numbers, and some examples are 4, 6, 8, 20, 27, and 100. These are all some examples of composite numbers. Any number that is a multiple, so like we saw back here, all these colored numbers, remember they were multiples of numbers? That's how we found them. Any number that is a multiple of another number is a composite number. So this is just a key word. Make sure you write that down. So for example, 4 is a multiple of 2 because 2 times 2 gives you 4. Therefore, 4 is a composite number. 10 is a multiple of 5. Therefore, 10 is a composite number. Okay, so pause the video until you have all that written down. Okay, just remember, prime numbers only have two factors. Composite numbers have more than two factors, or multiple curves, many curves on their factor rainbow. Pause, and when you come back, we'll be ready to move on. Okay, so one of the last things I want you to do today is to answer these reflection questions in your exercise book. 4 little quick questions. What did I learn about today? Did I find it easy, just okay, or hard? I want you to give me an example of a prime number and an example of a composite number. Don't worry, we'll be doing a little bit more work with prime and composite numbers, and you'll continue seeing this in grade 7, 8, 9, and so on. Okay, so this is just, I believe, your first introduction to this. I don't know if you've done it in grade 5, but it is something we'll be working with, and you'll get used to it when you do more examples. So pause, answer these reflection questions. When you come back, I'll give you the practice work that goes along with this lesson. Okay, and the last thing, guys, here's your practice work. Not very many questions from the textbook, but we have a little worksheet to go along with that, and you'll have some time in class to work on that. So that's section 1.3, prime and composite numbers. Make sure you know what is a prime number and what is a composite number, and make sure you get your practice work done.